Today I'm going to take a look inside of the indoor display unit for the weather station that I took apart in the previous video. This display unit can show the outdoor temperature and humidity, wind speed and direction, average and maximum wind speed I think, some other details that can be switched such as indoor humidity and temperature, rainfall rate, and more. This can display the rain, low and high temperatures or something, and some additional information here. It originally was used on this stand so it could be stood on a counter like this, but because I took apart the sensor, now we should take a look inside of the screen. This battery compartment would hold 6 AA alkaline batteries. These batteries are for battery backup, as the weather station is intended to be powered from a 5 volts DC power supply, and I don't know what the USB port is for. In the back there are options for also selecting the channel, clearing information from today, or clearing all the saved information, and factory resetting the device. But now, let's take a look inside this display unit. I've removed the screws and it should pop apart, revealing. That's interesting. This unusual sensor with this yellowish green film over it says pressure down here, so I assume this is the pressure sensor. Inside there's the USB and power interface board, a buzzer, battery wires, this display driver board I think, this board for one of the push buttons, and now I can see what temperature and humidity sensor the indoor unit use. It appears to use a thermistor for sensing the temperature, and this humidity sensor for sensing the humidity. Disappointingly, this is just glued in, not screwed down in any way. This is much more disappointing compared to the digital temperature and humidity sensor used in the outdoor unit. Now I'll remove the board that holds the push button, or one of the push buttons. This is the one that selects which setting it displays, and it uses 2 PCB mounted switches. Next, mounted using electrical tape, appears to be this copper wire antenna going to a module which connects to the board with 4 wires, one for ground, one for power, one for data, and a enable signal. But let's focus on this back cover, so I'll remove the interface board. So this board has the factory reset and clearing buttons and channel selection. Interestingly, each switch is at a different orientation, and these are surface mount push buttons. The orientation is probably so they could get the trace routing in the PCB the way they wanted, although it seems weird considering this is a double layer board. And then under this holder is another board which holds the power connections. This holds the power jack, a capacitor, and some transistor, I assume? Transistor says 7350-A QN1612. This could be a voltage regulator also. And then the USB port. And then the mini USB can be removed. This contains a crystal oscillator, some capacitors, some transistors, resistors, other capacitors, and a chip under this epoxy blob for interfacing with the USB port. And then the piezo buzzer can also be removed. It's just glued in, and these wires can be removed, separating the back cover. Next, I'll remove this board, which appears to be based on its placement, the LCD driver and touch control board for the touch button to turn on and off the backlight. for connecting to the LCD. It has all of these pads on it, and this is the touch button, which is just melted into the plastic. Looks like some permanent mark on the cable. Now I'll remove the main control board, which also interfaces with the front buttons. Interestingly, this one has 3 epoxy blob chips, probably one for the buttons, and one for the microcontroller, and one for running the screen. Now, is there any other screw holding it in? Nope. Let's try and remove the board. There's some wires going here for the backlight, I think. I'll cut the wires. This LCD uses this backlight underneath it to provide the reflective layer and also the backlight. Here are the buttons for accessing all the different functions, and another connection point for the LCD to the main board. Let's pull this off. Now, removing the LCD shows this flat panel backlight. And then I can remove this printed paper which provided all the background on the screen. And this LCD is very reflective and also surprisingly transparent. It only darkens the image a little bit. Let's take this out. This is the LCD. This copper wire routed all over here to this module. Seems to be the radio receiver for the wireless sensor. On the wireless board, it also has this crystal oscillator on it. Now looking at the main board in more detail, starting over here, there are a few diodes from where the batteries came into the board, probably for reverse polarity protection, some capacitors and chips, an inductor, probably part of voltage regulation, going into all the control chips. Here's the pressure sensor, there's an 8-pin chip here, another one of the epoxy blobs, there's a crystal, and interfaces for the buttons, wireless, and temperature and humidity. Now, I wonder what happens if I connect this LCD backlight to a bench power supply. I now connected the LCD backlight using this pinout on the side showing the anode and cathode of the LED to a bench power supply currently set at 1 volt of 20 milliamps and no current draw. Increasing the voltage to 3 volts, which is a common forward voltage for white LEDs, it draws 56 milliamps. And I was looking at the wrong side, and you can clearly see the backlight is on. And if I put this graphic over it, you can see how it would illuminate this as the main backlight for the LCD. As this is an edge-lit backlight, you can see there is some uniformity issues around where the LEDs are located. But anyways, this is what is inside of the indoor unit of an AcuRite weather station. So make sure to subscribe for more videos.